So again, the two outcomes now are the earthquake either happens or it doesn't happen. Okay, well, if the earthquake does occur, right, the company has to pay $60,000. They're going to lose that money. Okay, but they gained $100 from the person who bought the policy, but they're going to lose $60,000. So from the outcome that the earthquake occurs, they lose $59,900. Okay, well, what's the probability though the earthquake happens? That's 0.0013. So what's the probability that this outcome occurs? 0.0013. Okay, so again, the probability of this happening where they lose this amount of money is 0.0013. So what's the product here? We multiply, we get negative 77.87. What about, okay, so what if the earthquake does not occur? Well, they still get $100. You know, you still buy, they still sold the policy. So they still have the $100. What's the probability the earthquake does not occur? Well, this is the probability the earthquake does occur. The probability it does not, that's the complement. So it's 1 minus this, which is 0.9987. So now we just multiply the two, right? They win 100 times 0.9987. You get 99.87. You add up the two products, you get $22. So for the company, they should use this policy. They should sell this policy, that is. Because in the long run, from each person, they're going to gain $22. That's what this is saying. So they should. So this policy is good for them. Okay, good. So we have that. So here's another example. This one, I was going to have everyone try as well. So, I mean, you could pause the video now and try this on your own. Well, I'm going to do those. I'm just going to keep going and go through this. So let's suppose a bag contains 2 gold marbles, 10 silver marbles, 25 black marbles. And let's say someone offers to play this game where you randomly select a marble from the bag. Okay, and again, we're assuming that the marbles, you cannot tell by feeling them which is which. You know, that's something we're assuming. If the marble you chose is gold, you win $3. If it's silver, you win $2. But if it's one of the black marbles, then you lose $1. So the person playing the game loses $1. So what is your expected value if you play this game? Okay, so what is the expected value for you is what we're asking if you play this game. Okay, so there are 3 outcomes now, right? 3 outcomes, right? There's a gold marble you can choose, right? And if you choose the gold marble, you win $3. Okay, what's the probability though? Well, there's 37 marbles. They're all equally likely. There's 2 gold ones, so it's 2 out of 37. So again, what's the product? 3 times 2 over 37? That's 6 over 37. But what's another outcome? Silver marbles. That is, you can choose a silver marble. Okay, so if you choose a silver marble, you win $2. What's the probability of that though? Well, there's 10 silver marbles, so it'll be 10 out of 37. So multiply the 2. 2 times 10 over 37, 20 over 37. What about a black marble? Well, if you choose a black marble though, you lose $1. How many black marbles are there? There's 25, right? So we get the product, -1 times 25 over 37. That's just negative 25 over 37. We add up the products now, okay? You know, there's a common denominator, so you're really just adding the numerators. You get 1 out of 37. So theoretically, you should play this game. That is, you want people to play the game. Okay, you know, you're running this game, you want people to play the game. Because our expected value is positive. Okay, good, good. Let's change this a bit. Let's suppose instead, if you choose a black marble, you lose $1. Okay? Okay. Let's say now instead of losing, excuse me, not $1, we lose $2. Okay, so this time when if you choose a black marble, you lose $2. That is, the person playing it gains $2. What about the expected value now? Well, the only thing that's really different is in the table is the bottom row. You know, we're not changing how many marbles there are. So instead of having -1 down here, we have -2. And this turns out to be, this product then will be -50 over 37. So now we add up the products. You know, the other two are the same. 6 over 37 plus 20 over 37. Okay? Minus 50 over 37. Now we get -24 over 37. Now it's negative. So now we should not have people play this game, okay? We should not have people play this game. Because now the expected value is negative. Okay? So in this case, we don't want that. Okay? Because we're going to lose in the long run. Okay? So that's why. Okay, let me just fix one other thing. The player earns. Let me just fix that. Just want to fix this. So I think on the other slide there was a mistake. Okay, there we go. Okay, now I feel better. Okay. Okay, good. All right, now I think that's as far as I got in class today. This example I was going to do, but we ran out of time, so I'll stop here.